Time to fault find my old SEC 20 amp power supply. Gives out roughly 13.8 volts at 20 amps, and it just popped a fuse, and it popped it real good. So I'm suspecting it's the fuse that blew. Focus, please. Yeah, because it's not going to focus. Yeah, so that's the fuse that blew, and it blew pretty violently. So I'm going to investigate what's going on with the power supply. And there wasn't anything short circuit across the terminals, so it wasn't that. So we'll investigate further. I've connected a meter here across one of the smoothing capacitors on the output of the rectifier, and I'm just going to check for resistance here or continuity, see if there's any short on the output of the rectifier. And there is just over 1 ohm, nearly 2 ohms, and that's probably the resistance of these cables, because they're not very good cables. So yeah, we have a short. We have a short across the output of the smoothing caps. Disconnected this this wire here, which is the output of the rectifier that goes into the smoothing of filter capacitors, and that comes off the bridge rectifier down here and off the positive output of the bridge rectifier. And I'm going to check the rectifier, see if there's any short between the input and output. So the negative part of the rectifier, or half of the bridge rectifier, is actually not being used on this in this case. Okay, so I've connected the meter across the positive output and one of the inputs to the bridge rectifier, and I'm just going to check the resistance, and yep, sure enough, it's about 2 ohms. And if we go on to continuity, you can hear there's a short. So there's a short right across the bridge rectifier, and the output of that bridge rectifier is disconnected here, so there's nothing else it can short to apart from itself. So the bridge rectifier is short circuit. And for those of you that are going to say, well, it's across a diode, let's reverse the terminals, and we still have a short. So yeah, the bridge rectifier has gone short circuit, so I need to find a replacement. Now this this power supply is a 20 amp power supply, so I need a good sized bridge rectifier to replace that one. At least 20 amps. I'm probably going to look for something that's capable of 30 amps to upgrade it a little bit, and that'll be the next step, to take this one out and get a new one in there. So here we can see that what should be a diode here in this position is reading totally short circuit, and if we go to the other side, we should get a diode potential. So we've got about 0.53, which is normal for the silicon junction, and this side we've got a short. And if I do the same test on the new one here that I've got, we've got, should have here, it's difficult with one hand when you're holding the phone or the camera with the other hand. So here we've got the diode junction, which on the other one, the faulty one, that's a shorted diode. And then if we go to the other side, you should see another diode junction, which we do. We're not going to use the negative output here anyway, but that would be the equivalent circuit that we're talking about. So we've got the AC goes in either side, the AC here, the AC goes in here, and then just the positive cycles, or half cycles I should say, come out here. And because we've got the AC being fed into the two diodes, every time this goes positive, this diode conducts, and every time this goes positive, this diode conducts. So if the supply voltage is 60 Hertz, we've actually got 120 Hertz positive pulses at this point here, which then gets fed to the filter caps or the smoothing capacitors. See here the replacement bridge rectifier here, the KBPC 50-10, and the original, the KBPC 3502. This is a 30 amp diode, bridge diode, and this is actually a 50 amp bridge rectifier. So it's interesting that this is actually smaller than the original one, just slightly, but much higher rated. It's actually rated to 1000 volts peak inverse voltage as well, so it's very capable of handling the 20 amps that this power supply is capable of delivering. So I happen to have quite a few of these in my parts bins. I ordered something like 20 or so of them about a year ago, and I thought, well, I'd order some of these because at some point I'm probably going to need them on various repair work. So this is a good universal replacement bridge rectifier. So I've just replaced the fuse, and I'm going to check the transformer output from the secondary. I'm just clipped my meter onto the secondary output connections before I hook everything back up again, just to make sure the transformer is still functioning properly. And I'm going to turn it on now, and we've got about 32.5 volts AC coming out of the transformer, so that's good, that's fine. And I was just concerned that the transformer was pretty hot when I turned it off, or when the fuse blew earlier. Took it apart and the transformer was really hot, so I was concerned that the transformer was damaged, but looks like the transformer's fine, so that's good. So the bridge rectifier is replaced, and it looks like we're ready to turn it on and give it a try, see what happens. And there we go, it's working again. Roughly 13.8 volts, which is the correct output for this 20 amp power supply. So bridge rectifier replaced, and everything's working again now. Oh, obviously I replaced the fuse as well that had blown. So thanks for watching. If you enjoyed the video, give me a thumbs up and subscribe for more videos. Thanks again. Bye for now.